If you're a relatively new engineer, then having a solid understanding of signal flow will not only improve your mixing techniques, but it'll be the key foundation required to working in studios that are high-end like this one. Hey guys, Jake and Evan here from Mix Philosophy, and today we're going to be talking about how to understand and conceptualize signal flow. This may seem like a bold statement, but understanding where your audio is traveling and what is affecting it is key to troubleshooting almost every problem you'll run into in a studio.
Signal flow is the literal path that audio takes through various hardware and software units to get to its destination, i.e., your ears. This explains how a sound can get into a microphone, be processed, and eventually get back to your ears. Let's start with the most common and basic signal flow. First, you have your microphone. The capsule inside of it turns discrepancies in air pressure, also known as sound, into an electrical signal that can then be passed through an XLR cable. At this point, if you're in a professional studio, the mic signal will most likely be wired up to a preamp using a patch bay. A patch bay is simply a collection of inputs and outputs that conveniently puts all of your gear right next to each other. We'll talk about patch bays more in an upcoming video, but the important thing to remember is that your outputs will be at the top and your inputs will be at the bottom.
So finally, it's time to send your mic signal into a preamp. What a preamp does is it amplifies the mic level signal into what's called a line level signal so that other hardware and converters can use it. A mic level signal straight from the capsule won't be loud enough for converters or other hardware to process it, so preamps are specifically designed to amplify that signal to line level, which other hardware and converters can use. Next is your converter, or your interface. These are typically referred to as converters, DACs, or ADDA converters. It's important to realize that not all converters are created equal, and some of them only serve a specific function. Some consumer converters will specifically be digital to analog or vice versa. Professional grade converters are usually both analog to digital and digital to analog, although with some exceptions. Some extremely high-end mastering converters will specifically be A to D or D to A. Smaller format USB interfaces like this one that are built for consumers often act as the preamp and the DAC. This is certainly helpful and aids to streamline the recording process, but in larger format studios like this, there's much more capability to be creative with your routing.
Now that you've converted your audio from analog to digital, your DAW can now see it for recording and mixing. But of course, you'll need to turn it back into an analog signal to hear it through your speakers. That process is known as digital to analog conversion. It's the combination of both A to D and D to A conversion that lets us do our work. That's what makes interfaces like the Scarlett 2i2 so incredible. It's cheap and allows you to have both levels of conversion easily.
In most home recording setups, the monitors will be plugged in directly to the back of an interface, such as the Scarlett 2i2 or an equivalent USB interface. However, in a larger format studio such as this, there will likely be an external controller in between the sound itself and the monitors. For example, this could be a small format monitor controller like the Mackie Big Knob, or it could be something like the monitoring section on the SSL right here.
So why do we put such a strong emphasis on teaching and understanding signal flow? The first big reason is troubleshooting. As your signal gets processed through EQs, compressors, and whatever you might choose, it's going to make a sonic difference if there's a problem at any point in that chain. 99% of the time, an issue you're having is likely due to your inputs and outputs flowing incorrectly.
In addition to being able to troubleshoot routing problems in the studio, understanding signal flow will also help you better utilize your toolbox as an engineer. Is your EQ coming before the compressor? Or is the compressor coming before the EQ? Both have benefits and a different sonic flavor, which you'll have to decide for yourself which is best. We'll talk a little bit more about that later.
That being said, the worst thing you can do for yourself is mix without intent. If you're using techniques you know you like the sound of, but you're not actually listening to how it's affecting your mix, you're doing you and your client a disservice.
Facts.
Now we're going to go over a few microphone setups that have varying levels of complexity in terms of their signal flow.
The most common home studio signal path involves one of these, a basic USB interface. They're small, relatively affordable, and typically contain preamps, line inputs, a monitor section, and a two-way converter. In your home studio, all you'll need to do to record with one of these is ensure your DAW is communicating with the interface, plug the microphone, turn up the gain to a level that doesn't turn the red lights on, and record away. The interface handles the A to D conversion so your DAW can record incoming analog signal, as well as the D to A conversion so that you can use the monitor outs, which are typically on the back of a small unit like this one. Alright, so let's step things up a little bit now. Right here we have a pretty simple vocal chain for a larger format studio such as this one. We've got the U87 here that's running down to our snake on channel 1. So then we're going to patch out from channel 1 on the snake into the input of our preamp. Then we're going to go out from the preamp into our DAC. All we have to do is set the gain on our preamp and make sure we're not clipping, and it'll be perfectly fine. No funny business. So what you're hearing right now is my voice being processed through the U87 and then into the Vintech VA73. As of right now, we aren't putting any extra compression or any other hardware on the chain. If Evan in the control room was to turn my gain up or down in the middle of recording, there would be sudden changes to the volume and the tone, which would make it overall very difficult to mix. Alright, now let's say you have a little bit of extra hardware you want to add into the mix. How about we compress this vocal a little bit on the way in? So now when we come out of our preamp, instead of going straight to the digital audio converter, let's go to the distressor first. So we'll go out from our preamp into the distressor, and then out from the distressor into the DAC. A lot of engineers like to add a subtle amount of compression on the way in, but remember, there's no way to remove it, so just make sure you're not using too much. So what you're hearing now is my voice being processed through the U87, our preamp, and now the distressor. In this scenario, if Evan sets the preamp on the gain too high, the input section on the compressor won't work like we want it to, and we won't have as much control as we'd like. So now for our most complex vocal chain, we're going to add a second compressor on the way in. Now when we come out of our preamp, we're going to go over to the Universal Audio 610 compressor before we hit the distressor. The thing about the 610 is it includes both a mic and a line input, so we'll need to make sure it's set to line, being that our signal has already gone through a preamp. As our vocal chains get more and more complex, we'll need to make sure that we're paying super close attention to the gain staging at every step of the way. If at any point in time the signal gets turned up too hot, it'll distort and there will be no way to remove it. So what you're hearing right now is my voice being processed through the U87, our preamp, the UA LA610, and then finally the distressor before hitting our DAC. In this scenario, if Evan were to change the compression on the 610 before it hits the distressor, the audio that will be going into the distressor will be different and will be processed differently. Being that the 610 is the middleman in this stage, it's super crucial to make sure that it's not outputting too much into the distressor, which would cause unwanted distortion. So let's take a quick listen to what that would actually sound like. Right now, Evan is driving the output of the 610 into the distressor way too hard, and you're hearing my vocals start to distort. If the sound was recorded like this, it would be pretty much irreversibly recorded that way, and there would be no way to restore the clarity. In a nutshell, that's why gain staging is so crucial. In addition to considering the signal flow between our microphones and our hardware, we can also consider the individual pieces of a unit like the SSL here. So in any large format recording studio, the console is going to be the centerpiece as well as probably the most intimidating piece of hardware in the room. A lot of people think that recording consoles such as this one are super hard to understand simply because they have a lot of knobs. While it's true that consoles are great at having a lot of knobs, the main purpose of owning one is condensing the signal flow process into a single unit that you can use on a bunch of different channels at once. I feel like people are often intimidated because they look at a console and read it from left to right and wonder what these 40 green knobs are supposed to do. But in actuality, if you read it from top to bottom, you'll see that it's the same set of controls for every single channel. Let's break it down. So up at the top here we have our input sections. Over here we have a mic and a line that we can flip between depending on which type of signal we're getting. We can control phantom power and padding, or we can even flip the phase if we need to. Below that, we have a built-in high-pass filter on every channel. We have a video on those, you should go check it out. And that sits right above the normal 4-band EQ section on the SSL. Different consoles will have different controls for each of their respective sections. But on SSL consoles, you can always recognize them by their signature colored EQ bands. From top to bottom, we have high frequencies, high mid, and low frequencies. Unfortunately, we don't have any hardware configured to work as an analog insert on the SSL right now, but it works the same way an insert effect would work in your DAW. Here we have a button to set the EQ before or after the insert were it being used in the chain. Immediately down below here we have an option called Direct Pre, which allows us to record the signal back into the digital audio converter before it has to deal with panning or any of the faders, which we wouldn't need if we're just recording a signal. If we are planning on mixing using the SSL, we have some cues here we can use for different send effects, a pan knob, and finally 2 separate buses we can use. One is labeled record and one is labeled mix. These can be used to sum or monitor audio however you like. Just remember that they're analog, so they'll need to be printed back into your computer if you want to export it. Now when we say the recording and mix bus here on the console, we mean two specific sets of outputs that the SSL has that you can route back into the computer to do whatever you like. You could use the recording bus to get a mix on the SSL going for people's headphones while recording, or you can use the mix bus to mix a song fully and print it back into the DAC. Just like we patch a microphone into a preamp or a compressor, there's a separate patch for the mix bus out on the SSL that'll go into your input channel of choice. Down here below we have digital pan buttons for controlling a DAW, and then we have faders that can be configured to work either analog or as digital MIDI controllers. If you're mixing analog on the console, you can sum all of the audio through the bus compressor in the master section. This will allow you to compress all your audio one final time before it gets sent back out to your DAC. The console format was designed specifically to streamline the signal flow process for large format studios such as this. The predefined signal flow paths and the fact that preamps, EQs, compressors, inserts, and sends can all live together in the same physical unit makes it incredibly easy for an engineer to get a lot of work done sitting in just one place. Owning a 24-track analog console such as this essentially can save you from doing 24 channels worth of patching to an EQ or a compressor. That's it for this week on Mix Philosophy. My name's Jake.
And my name's Evan.
And we hope you learned something valuable today, even though we know this is a lot of information presented very quickly.
If you have any questions, drop us a comment down below and subscribe if you dig the content. Peace.